So we've learned that for a system of equations, that when you graph it, the intersecting point is the solution. It is the ordered pair that's going to make both of these true. So to solve a system by graphing, we're going to graph both equations in the same coordinate plane. Then we're going to write the coordinates of the intersecting point, like we did in those last problems. Then we're going to substitute x and y into each equation to check. If the point does not check, your graphs may not be correct. It's pretty easy to make a mistake when you're graphing. All right, so let's graph. So we have x minus 2y is equal to negative 2. Let's solve it for y. So I'm going to subtract x and get negative x minus 2. Then I'm going to divide everything by negative 2, and I will come up with y is equal to, two negatives makes a positive. This is going to be 1/2 x, and then two negatives make a positive, plus 1. So we get y equals 1/2 x plus 1. So we're going to graph that. Here's my 1, and it's going to be up 1 over 2. So I'm going to repeat that over and over again, up 1 over 2, and the same one, go down 1, back 2, down 1, back 2, and kind of put in all the points so we can see easily where they intersect. So here's my line. Now I'm going to graph my second line. So I have x plus y is equal to 4. So I'm going to subtract x from both sides and get negative x plus 4. So I'm going to graph that. So 1, 2, 3, 4, y-intercept of 4, and the slope is negative 1. So down 1, right 1, down. So you can see where it intersected right there, and that's really all we really need to see. So connect this, and we see that our intersecting point's right there, which looks like it's the point 2, 2. So 2, 2 is what we're going to say is our solution. Now let's check it. So when we check it, we're going to put 2, 2 into our equation. So that's going to be 2 minus 2 times 2 is equal to negative 2. So 2 minus 4 equals negative 2, when we can see that that checks. Then over here, for the second one, putting 2, 2 in, we get 2 plus 2 is 4, and we can see that that 2 checks. So the ordered pair, 2, 2, is our solution. All right, so now let's do this next one. Same thing. I'm going to graph it. So I have x plus y is 0, so y equals negative x plus 0. So that means there's a y-intercept of 0 and a slope of negative 1. There's that negative 1 slope again. So that's just going to go down and up 1, back 1. So we have our ordered pairs here. And then we'll graph the second one, which is x minus y equals 4. And so that's negative y. I'm going to subtract the x from both sides, so that gives me negative x plus 4. Then I'm going to divide everything by negative 1, and I'm going to get y is equal to a positive x minus 4. So here's my minus 4. Y-intercept is going to be up 1 over 1, up 1 over 1, and we see where it intersects right here, which looks like it's 2, negative 2. So we want to check that answer. So putting a 2 and a negative 2 into my equation up here, I'm going to have 2 minus 2 is 0. We see that checks. And then plugging into the second equation, we get 2 minus a negative 2 is 4. So that's 2 plus 2 is 4. And that also checks. So 2, the ordered pair, 2, negative 2, is our solution. So in example 4, I cheated a little bit. I've solved both of these for y, and I'm going to graph them. So I have a negative 1 from a y-intercept, and then a slope of 2, so up 2 over 1, down 2, back 1. You can kind of see where this line is going here. And then the second one, you can see it right there. These lines are parallel. Has a y-intercept of 5 and also a slope of 2 over 1. So we're going to kind of repeat the 2 over 1. And from previous experience, we know that those are parallel. So where do they intersect? They don't. So this system has no solution. Or we could draw the circle with a line through it, because the lines are parallel.